27th of May 2026. Today we're going to be talking about links on the Modarra bracelet. There's a few different designs of these links that I want to go over. There's a very small details, so I've shown them in the first video, but I really want to show these up close. There's a few little tiny details, little chamfers and fillets and radiuses that I want to go over this. I've got Fusion pulled up. The goal is to make a master file, work on making a master program and dialing in how we make these links on the 5-axis. Right there, between my thumbs, we have two different link designs. You can see the one on the right doesn't have much of a radius on the edges, and this one has much more pronounced radius, or a fillet, and you can see it there as well. So the question is, which one do we go with? And the one on the right, the sharper one, was the first design I had. Just simply, it was easier to make, machining, if you will, 3D surfacing, and it was just like what I had in my brain initially. Then I made a handful of them, as you can see. I thought it would be too sharp. I thought they looked too boxy and bulky. And so then I made these versions here that all have way heavier of a fillet, and they're just more rounded. And here you can see there's two flat ones on the right and two radius ones on the left. I like both of these. Now, I think we've got to pick one and make that the first design, and then we can play with this later. The clasp, I guess that's something to think about too, is which one looks better with the clasp as well. The way the clasp I have is pretty heavily radiused. That's obviously totally changeable. I mean, any of this is changeable. Let's see if I turn this down. Is that a little bit better? Again, we have some decisions to make, but the more I wore it, and after polishing it, I actually really like the boxier look. It reminds me more of like a watch band. And so I think that's what we're gonna go with, and then later on come out with the radius version if people want it. But I really like how this one has more surface area to it, if you will, especially when it's polished. So the one thing that is difficult about this is the way I'm making them is we have to deburr them as much as possible in the machine, because tumbling isn't going to remove a lot of material unless it's really aggressive, but I don't want that. And so if you see here, see this one there, you can see that little like chunk that's been taken out. That's because I tried to put a chamfer on it and the tool was slightly mismatched, and it cut, or a fillet, sorry, on that sharp edge, and it cut too much into the side of the part. And then I think I ended up removing that from the program, and it was just sharp edges. So the edge that we're talking about here, if I get a pointer, is this right here. These two edges here. They're not sharp, but they do catch if you're not careful. So we definitely need to put a radius on there of some kind. And that's going to be tough to do without getting a mismatch. So it might be a chamfer, because we could cut straight across and we wouldn't have any mismatch. There's a risk of it being a heavier chamfer on one side than the other. So this is something we're going to have to play with. Okay, so in Fusion, this is the radius that we're talking about. As of right now, what I was showing you had no fillets on it here, but it created these sharp edges here and here. Now again, the way the links interact, there's not much for this to catch, but I think we need to add just the slightest radius, not much. I mean, something like that, 15 or 20 thou, I feel like would be just enough where it doesn't take too much away from it. Now, the other thing is, this is kind of a rough part file with no fillets or anything on it. In reality, what this is gonna look like is it would have probably, let's say 20 thou there, and I think I had 10 thou or 15 thou on the outside edge, even on the sharp ones. They don't look like they have much of a fillet on that longer edge, but there is one. So I'll probably have to check back my older files, but in theory, it's gonna look like something like that. I think that's too much of a fillet on this side. I think that would look better when we do like the full radius, like heavy radius, something like that in the future. But I think for now, that is too much. So I'm probably going to probably gonna delete these, and I'm probably 20 thou. I think I'm gonna check back at my old file and see what these were, and match that, or maybe increase it slightly, but that's kind of where my head's at as far as that goes. So I'm gonna work on that. I'll show you guys the program a little bit more here, and then we'll go out to the machine, we'll make one. The other thing we have to figure out is the depth of this hole is something, this one here, where the screw bottom's out, that's something that we're gonna have to play with a little bit more. I'm currently boring both of these holes because this one does get threaded for 440. This one is simply just a bore. I might end up drilling both of those in one shot to save a little bit on cycle time and tool life, but I'm also boring this because I really want the accuracy, but and I do like the flat bottom hole here, and there's not much material here to work with, only like 20 thou. So I'm gonna check back, figure out what these fillets should be. The other thing that I was just gonna mention is we make these upright like this, and then op 2 is, well, there is no op 2, is there's a tab left on this radius here. I don't like that because there's no good way to remove that radius. So what I'm thinking is, right now I have the tab off to one side. I'm thinking what I'm gonna have to do is center the tab, and then there might end up being a small flat, and these might have to have an op 2 where we flip them over and I buzz off the top, and so there's gonna be a small flat. Now, if that's the case, depending on how much we take off is gonna create a really thin section and an already really thin part. I mean, that's already only 13 thousandths of an inch. So I might have to beef this up for an op 2. So that's kind of the next thing. So the first step is let's nail down these fillets. Let's go make a few of these and then figure out how the heck we're gonna do op 2. Okay, I just played with some finishing. I wanna see if I can show this. So the far left link, it's gonna be really hard to see. You can see it's got, from this orientation, horizontal machining lines going this way. The next link over, I took and I flat sanded, let's see if I can get this just right. I flat sanded with 400 grit, and now we have vertical sanding lines, but no tool marks. Maybe if I pick this up and kind of angle it in the light, you guys will be able to see that better. Yeah, you can see the vertical sanding marks a little bit more. Let's see if can I overexpose this? This is gonna be tough. There you go, you can kind of see that. So yeah, now we got vertical sanding marks. So we started with this, right? Then we went to this, and then I did this on both of these. So this is like off the machine, 400 grit. This is then 400 grit and then 2000 grit. So it's even smoother. But hopefully you guys can, it's so tough to focus on something so small. But hopefully you guys can see that it catches the light more, and it's definitely smoother. You're gonna have to trust my eye here, but it's not polished. And based off of the ones on my wrist that are polished, some of these give off way more light. So I think that's a good route to get rid of the machining marks, but I think we're still gonna have to tumble in some kind of a polishing compound to bring out the shininess of the stainless. Another thing that I'm gonna try to figure out is with these, where the radius ends, it's kind of a sharp line. I don't know if you can see, like right above my fingernail there, it's kind of a sharp transition line. That's gotta be something toolpath related. So I'm gonna try to fix that as well when we're making these. And then the other question is, how do we, if we do have to sand these individually, which I really hope we don't, I hope we can figure out some aggressive tumbling method that will evenly pull out the machining lines, and then another tumbling method to polish, because otherwise we're gonna have to sand like that on both sides, like that on both sides, and then we're not touching the radiuses at all. So, like I said, finishing on some of these parts is going to be the process here that we're really developing, is how do we finish such small parts. So anybody has any information on tumbling that they think would work on this, I'm all ears. So that's something I wanted to go play with tonight. The machine is currently busy making something, so I can't go down there and make links, but the next video clip should be us playing around making a new link. So yeah. Okay, so I've reprogrammed the new link. I made a new file that has the new fillets and all of that fun stuff on it. Now, what I'm playing with now, it's still loading here, we're simulating, is how I'm tabbing this part off. I'm trying a different tab method than I did the first time. I think I mentioned how I did it off to one edge here. This one will be a center tab on this radius, and then I'm going to come in and make the tab even smaller before it gets fully like cut off, if you will, or gets to the point where it's going to just fall off if I machine anymore. So I still think the tab is a little bit too wide. I'm using an 1/8 inch end mill. Let's wait here for this to load a little bit more. And I might have to drop down to something smaller, 1/16 of an inch. I really don't want to, because I want this radius to be cut with the same tool. Okay, so here you can see I am machining this pretty thin. You can see that this is an 1/8 inch end mill coming in here, creating this, and you can see this is basically the width of the tab right here. So the problem with that is if I go to do an op 2 from about here to here, that's where we would have to machine this flat, and then this gets extremely thin. And if I rotate this, you can start to see what that tab would look like. Now, the problem is I don't know an easy way to finish this if I don't do an op 2 in the machine. I really don't want to have to do an op 2 in the machine. This might be small enough I could hit it with sandpaper, and then after tumbling it could blend. That's one hope. It's this weird limbo where I still don't know how these are going to get fully finished. I have an idea on how I'm going to finish the flats, but regardless, this is going to get tumbled somehow. So that's the current tab. I haven't tried this yet, so we're going to try this. You can see I have this fixture where I'm making, what is this, 2, 4, 6, 8, 9 of them at a time. I'm only going to make one at a time here, and we're going to prove this out. So I got to figure out in Fusion how I get rid of this pattern feature, because right now everything's patterned. Alright, so we're going to be using the TRT 210 here. I'm going to put in some parallels here. We've got our fixture that'll go in here. So it's just a piece of steel with these V channels cut in them, and then we've got set screws. This seems to work really well for holding the parts. There's not a lot of machining forces that are on them. So we're just going to be using this first spot for now to prove out our program, and then we can pattern it across and do a whole set. And that'll obviously speed up cycle time because it'll be a lot less tool changes. We can use the first tool, 3/16 end mill on all of these parts, then change to the 1/8 inch end mill and go to the ball mill, etc., etc. So this I made a while ago for testing, and it's been great. Before, what I was doing was I was using a collet block and putting one little stick of material in one at a time, and that was a pain in the butt because I had to undo the vise, take the collet block out, undo the collet block, reset it every time, versus this I can just leave it in the vise and I can do everything with an Allen key. One thing that we are going to have to start to think about is, this is a bad part that I stopped for some reason, but as you can see here, we can focus this. This is a little bit long, but there's a lot of wasted material because we're putting this in here like so, and part of the reason we need some of the height is to get further away from the vise and the fixture so we don't have any collisions. So for now this is okay because we're just testing, but once we go to production we're really going to want to start to think about this from a cost perspective. Luckily, this material is pretty inexpensive. It's not like this is titanium or anything. But when we go to those more exotic materials, this is something we're gonna have to start to really think about. Obviously, I fully understand that this machine is not the ideal machine to be making these parts, but it's what I have. And until we prove out the business and the products and whatnot, I think we're just gonna have to use this. I think long term a Swiss and like a Wilhelmine style machine for something like this would work really well. So that's what we got for now, so we got to make it work. These are our constraints and we're gonna work with them. So I'm gonna load this up with a parallel and then get a little piece of material ready to go. I got a little piece of 1/8 inch steel in there from a screw test. So that's the beauty of this fixture, is we can use this for making the screws as well. One thing to note, I'm using these 1/4 inch thick parallels. Those are amazing. I used to have the 1/8 inch for the longest time, and going to those thicker ones is so much nicer. Highly recommend those. I'm just backing these screws up just so they're flush with the fixture here. I don't want them to fall out. I do need to order longer set screws for when we make our versions of our set screws to hold the material in there. So, because I'm kind of pushing it a little bit. So, I just torqued this down so the fixture's tight, parallels are tight. I guess I got to go over to the bandsaw and cut a piece of this, but before I do that, we can probe this. Okay, so let's move this guy over here, and I need to double check. I believe my Z0 is just the top of this fixture, but I know X and Y are just the center of this, so we're just going to center this up. Look, you guys. It's actually a pretty good angle, I feel like. Okay, so where's my tape measure at? 6 by inch. Yeah. Alright, so that should be fine. How did I do this last time? I think I might have done it off the corner, actually, because the center slot was, oh, maybe I just went further enough down. It's a good question. I don't remember how I did that. So I machined this edge around the top, and that was for probing reasons. I wanted something that was machined when I machined that. Now, granted, this really doesn't matter think I just went off the non-machine surface. I think that was fine, because if we're within even 5 thou on this, we're totally okay. So let's go ahead and let's just probe that. I'm gonna clean this window for you guys. So hopefully you guys can see. All right, well, that's gonna have to do for now. Let's probe this. We're gonna go edit, VPS, work offsets, rectangular block. We'll do 57, I think, is available. So I use 59 and 54 for something else. So we'll do 57. You don't want to probe Z. X is 6 inches. Z or Y is 1. Z. You're gonna want to go down. Yeah, minus 0.8 is fine. Let's turn that down and let's give this a shot. Yeah, that's gonna be fine. I'm curious though, if I check my program, what it actually was before. Okay, and then while I'm here, I'm going to probe Z as the top of the fixture, but I'm going to go confirm with my program before I run this. Something like that's fun. So we'll do single surface, minus ½ inch. Okay, so this should be fully probed in. So you guys in focus still? Yeah, okay. This should be fully probed in. I'm gonna go check my program. I'm gonna cut that piece of material. We'll load that up, and then let's run it. Okay, so we got our first blank, double checked, top center of this is indeed our G57. We've got a blank that's an inch, 1.56 inches long. I wrote that down because we're going to start with that and see how small we can get that in the end. But we don't need this thing to be completely bottomed out. We only need it to be enough to be contacting the set screw. So as of right now, let's see if I can... I don't know if you'll be able to see this or not. Yeah, maybe. You don't need it up against the floor of this fixture. So if I get in here, you just need it to be in contact with that set screw. So I'm actually able to come off the floor. That's probably 3/16 of an inch right there. So I'm gonna go ahead and tighten this down, and we'll find a torque value for this eventually, but I'm going just kind of off feel. But I mean, surprisingly, the bottom of these set screws actually dig into this steel just a little bit. It would be interesting if this is the way that we end up having to go just temporarily while we are using this machine to make fixtures. It would be interesting if we modified some set screws to have a little bit more of a point to them to really grip in to the material. I could see us doing like a crosshatch pattern of teeth. But for now, this is gonna do. I also just love how my bracelet is just always in the frame while we're talking about what we're working on. I think that's kind of cool. So, all right, that's in place. Program is loaded. We should be good to go. So let's see how our viewing is once we get started here. I might have to readjust, but let's go to this. We're gonna start off with a facing op. I'm gonna have to wait here for a second. I'm gonna go over to our safe position here. All right, how is our angle? I have no idea if I'm gonna leave this footage in or not, but I figure better to have it than See if I can try to focus it on there. All right. Now I gotta go full machinist mode here and watch this work. Okay, so already I can tell you our stock is too short for this program, so we're gonna have to repost. I had to reselect quite a few things geometry-wise. This should work. All right, let's give it a shot. Here we go. See what we got. There we go. So we're gonna face off a little bit here. Definitely a little bit of chatter there. 8,000 RPMs, 15 inches a minute. I don't remember the depth of cut. Okay, now we're gonna go in here and we're gonna cut the profile. I'm pretty sure this is just a contour with multiple passes. I really should change this to 2D adaptive, because I feel like it's taking larger cuts when it's entering there. Still 8,000 RPMs. This is 10 inches a minute. Again, I'm not trying to make this fast right now. Okay, so I think we've got finished cut. And then I think we're gonna rotate this bad boy. I'm gonna turn the camera off here simply because it's about to die and I wanna come back and show you guys the finished part. All right, so we just finished machining the link. There's a bunch of little tweaks to this that we got to make as far as tool paths go, some efficiencies on the machining side of things, and then actual cutting of these features. So we start from the top. I slowed down a few speeds and feeds. I added through tool coolant to a few operations. And then the first issue that I see, if we flip this link to the side here, when we go, let's see, where am I? When we go to cut this here, and we cut the fillets on these walls here. If I use my bigger example here. So we have a tool that comes in and it goes around like this and it cuts these fillets here and then it finishes this face as well. Now, the problem that I see, and I don't know if I'm going to be able to pick this up on camera because it's so small. We have one side here. You can see the fillets right there. Flip it over. See how it's like it's machining into this face here. I don't like that. What I'm wondering is, if I look at my tool paths, this is all done by Tool 22, which is a 3/16 end mill. And if I click through these, I'm wondering if that shouldn't be cut by that tool, if that should be cut later by a different tool. Being the 1/8 inch tool. But again, the only reason this would be happening is if this is shifted left or right just slightly. And I mean, if I look at this off camera, barely doing that. It's got to be like a thou or two, but it's obviously visible enough and I don't like that. And that would cause problems down the line in finishing. So I got to figure that one out. So I might try reselecting those finishing tool paths and have that get cut later by a different tool. The next thing is when we go to cut this slot in the top. So we have an adaptive tool, an 1/8 inch tool that comes through here, and full depth adaptives this, more or less slotting it. And then I have a finishing pass that comes in. Again, if I use my larger example here, it comes in and it finishes the floors and then this internal radius here on both these kind of tongs, if you will. The problem with that is I had a lead in and lead out that was set, and I don't know if you'll be able to see this. You can definitely see it on this side. Is it was cutting into, again, this surface here, and it was coming out and it was leading out and it was cutting this. It's barely noticeable, but the problem is again, I see the step over line and I can barely feel it with my fingernail. I don't know if I can show this right there. So I changed the lead out so it shouldn't do that anymore. So that's a pretty straightforward fix. Fillets on the top, these radiuses on the top of the tongs. I'm still getting this little step over line again. I think I showed this before, right there. You can see them. And I think the only way to fix that, I feel like that's probably my set bottom Z height for the toolpath. So maybe I have to extend that. But the finish on the tops of these is really nice. I'm really happy with the finish of those. But again, it's just a mismatch right there. You can see it by my fingernail. So gonna have to play with that. If we keep going down the tool paths, one thought was we also have, if I use my big example here, we have a fillet all the way around the top of this part. We're cutting it in a bunch of different operations with different tools, and I'm wondering if I should remove that and cut them all with the same tool. Because we have these internal ones being cut by the 1/8 inch, that's fine. But we have this top one in this orientation by the ball end mill, like so. Let's just do this, let's move this back. Like so, and that's cutting this outside part. The first tool that comes around and profiles this is cutting these long edges, and then we rotate it and we cut these 3 fillets here with the same ball end mill. So we're not using the ball end mill to cut all of these. I think that's a mistake. So I think what I need to do is remove the first tool that profiles this to not profile those fillets. When we come to rotate here, I'm just going to do all of these fillets in one shot. I feel like that's the best approach here. So it's gonna add probably to the cycle time quite a bit, but if that's what it takes, then that's what we're gonna have to do. Yeah, I mean, I gotta look at it this off camera. I guess I could kind of, it's just not gonna focus. I think that would clean up some of these fillets. One thing to note is this is, I believe, our 15 thou fillets. And if we lay this next to a 10 thou fillet, I don't know if you guys can see the difference. It's definitely, I mean, it's obviously more rounded. Hopefully it's not too much. So that's what I think I gotta also pay attention to. Yeah, then the tabbing didn't work. The tabbing, first of the, so there's 2 operations. There's the left and the right that do the final tabs that I showed you guys. And after the first one, this thing flew off. Luckily, I saw where it went in the machine. So you can see it's all chowdered up there. Yeah, and then I also think I'm gonna need to order a small little spot drill to chamfer this top threaded edge and then both sides of the link hole. I think they're just gonna, they have burrs right now, and I'm not chamfering this hole before I thread it, so that's definitely part of the problem. So that would actually add an actual decent operation there. So I think I'm gonna play around with these tool paths and I'll come back when I have something. this is now my, let's see, we did this one here, then we did this one, and then we did this one, and now we did the one I'm just on now. So this is the fourth one we've done. And we didn't fully tab it off. I could break that off if I wanted to, but this is going to be testing a lot of new things. So I'll get this off and I'll get up close with you guys. All right, so we've made 4 parts today, and let's see. This is the latest, and I'm going to try my best to show you guys the improvements here. The biggest thing was getting these flat faces to be as clean as possible, and then getting the edge breaks to work properly. So this is my pointer here. I hope that's gonna focus okay. So we'll just go for it. So you can see how these faces are nice and flat here. What we had on the first part, you can see those lines there and there. That was the lead out from this toolpath here. And then we were having these lead ins and outs mismatch because those were radiuses of the tool going around like this. So I changed them to chamfers. What I did was I changed these to chamfers, so now there's no lead in or lead out. Well, there is, but it goes off at an angle and it's tangential, so it doesn't actually touch this face at all. Even if it was mismatched, it would just make this chamfer slightly larger than the other side. But we're talking about literally like 1/1000th of an inch here, so you're not going to see it. But obviously, if there's a lead in or lead out mark on this face, you're going to see it like I just showed. So we got rid of that, and we did the same thing on these edges here. So now it's just a chamfer here and here, and then these radiuses are now changed to small 5 thou chamfers around. You can see the light hitting it there. That's all 3D machined from this orientation. This whole edge all the way around is machined in one shot using a 16th ball. So instead of doing part of the radius here, then part of the radius here around that side, and then doing it there with 3 different tools, we're doing it all with one tool in one operation, and then we rotate it and we do the same over here. So that has been amazing. This one I didn't drill or tap simply because I wanted to prove out everything else. The drilling tapping was fine up until this third part. I broke a tap. I don't know why. Along these long edges, I changed it from a fillet or a radius to a 5 thou chamfer. So we actually went smaller. It was originally 15 thou radius or fillet, and now it's down to a 5 thou chamfer, I think was what the original was. So I actually like this more. It's just enough, it catches the light, shouldn't cause finishing problems down the line. There's still a few minor problems with this part. We might save that for part 2. There might be 2 parts to the links because these might take me a little bit longer to figure out. But there are some tooling that I want to order. We are currently boring this hole here and this hole here that we tapped for 440. There's no real reason we need to do that the more I thought about it. The only thing that I need in theory is a flat bottom hole on this second tong here. That's for our custom screw to bottom out. I think we could get away with drilling both of these. I know for a fact we could get away with drilling this one. This one doesn't have to be tight tolerance really at all. I mean, with a carbide drill, I think we could hold ±2 or 3, that'd be fine. And it'll be way faster, that's the thing. So I timed it on the machine because Fusion sometimes, estimated machine time is not really that accurate. There's a lot of variables there. I timed the boring operation for this hole and this hole, and it was like 1.5 minutes. That, for a full bracelet, this is 25 links, I believe. I think that was like, it's like 30 some minutes. And we really got to start thinking about cycle time on stuff like that. So I think we're going to order some carbide drills for both of those. We might try a flat bottom drill, but I feel like we could get away with a normal drill. Or we could drill it and then come in there and bore it and clean it up. That would still be way faster than boring the whole thing. With the tool change, maybe, I don't know. So that's something I've been thinking about. I need to order like a small chamfer spot drill, something like that, because I think I want to chamfer both sides of this hole. On the actual parts, they are kicking up a burr. Let's see, only on the exit side. Actually, no, maybe that's the entry side. But I'd like to still kiss that while it's in the machine and just add a 1 or 2 thou edge break. I think that'd be really important to make it nice and clean. And then also to, like I mentioned, I'm not actually chamfering the drill and tap hole. I don't think that's why the tap broke, because ironically in that program I actually did add in a chamfer. I don't know why it broke after I chamfered it. That doesn't really make any sense, but anyways. Longer set screws for the fixture. Thread gauges are by Drills, talked about that. Chamfer tool, talked about that. Maybe some more 1/8 inch end mills, but stubby. Right now I think I have 1/2 inch length of cut, which is a little bit overkill. The gist is we're in the right direction. It's overall a success. I mean, I've done all of this in the past, like it's now 4 o'clock, almost 4 o'clock. What, 5 hours? Plus I haven't been doing this all day, so I feel like that's pretty good. Kind of the deburring of the part, I need to look at this under a microscope. I still feel like this could be better. I think we could end up just changing the deburr to all be a chamfer with the chamfer tool. That would be machine much faster, and I'm getting some inconsistencies here from, I'm 3D machining a 5 thou chamfer, so it's pretty small. Again, also cycle time wise, I know I could just come in there and hit that with a chamfer tool. I just don't have a small brand new chamfer tool, so I want to get something better. I think we're getting way closer to nailing down a model we like and starting to get a template of a program going, so I'm really happy with that. Still got to figure out how to tab these things off a little bit better. That's all I can say. I don't want to keep rambling, but that's where we're at. So this video is probably really long. Like I said, I might pick up where I left off. I'm machining all this stuff on Sunday, and then I'm editing the videos. So yeah, we'll probably see how this goes next Sunday. I don't know if I'll have any time during the week to play with this, but that's where we're at. Thank you guys for watching. Again, we are working towards building out a process to make these bracelets and future small, intricately micro-machined parts. Yeah, this is gonna be fun. This is gonna be fun to get to a point where I can finally sell these guys. That's the start of the journey. All right, guys, thank you.